Okay, 7th grade, this is the Chapter 4 study guide number 1. You need to have this out and follow along with me. We'll complete Chapter 4 study guide number 1 in class today through this video. And then your homework for tonight will be Chapter 4 study guide number 2, which is stapled to this study guide number 1. Tomorrow in class, on Thursday, I will check both study guides for completion. We'll go over study guide number 2 in preparation for Chapter 4 test, which will be on Friday. So here we go. Number 1. It says a student reads 120 pages in half an hour. Find the unit rate. Okay, so I'm going to show my work right here for number 1. You can either show your work on the study guide number 1 page or on a separate sheet of lined paper that you can staple together to the packet. All right, so number 1, I'm going to write the rate that the student is reading at. So write rate. The rate given to us in the problem is 120 pages per half an hour. How many minutes are in half an hour? 30. Okay? So there's 120 pages per 30 minutes, or half an hour. I want to find the unit rate. Unit rate. Remember, to be a unit rate, the denominator must be 1. Okay, so this is equal to how many pages per 1 hour. Now, 1 hour is the same thing as 60 minutes, right? And so even though our denominator is not 1 here, this is the same thing as being 1 because we could say 1 hour, right? So we can set it up by pages per minute, or we could do pages per hour, right? 120 pages per 1/2 hour, and we want how many pages in 1 hour. Okay, both of these are the exact same thing. We're just using we're using minutes here and hours here, obviously. But in both of them, look how we multiply the denominator by 2. To get from 30 to 60 minutes, we multiply by 2, right? 30 times 2 is 60. And using hours for the measurement of time, we can go 1/2 to 1. If we multiply 1/2 times 2, we're going to get 1. All right, so it really doesn't matter what rate you use. You can use pages per minute or pages per hour. Either one will give you the same exact answer. If you multiply the bottom of the fraction by 2, you got to do the same thing to the top. So basically, you're multiplying 120 times 2 to give you the number of pages per 60 minutes or number of pages per hour. So if you multiply 120 times 2, you're going to get 240. Okay, so if the student reads 120 pages in a half an hour or 30 minutes, that means they're going to read 240 pages in 60 minutes or 1 hour. So my final answer is 240 pages. Pages per hour. 240 pages per hour. That's the unit rate. Okay, number 2. Number 2 says, which speed is the fastest? And we have 3 options. 3 miles in 1/3 of an hour, 1/3 mile in 3 hours, or 1/2 a mile in 2 hours. So as you can see here, we're comparing miles to hour. So what we could do here is find the unit rate for each of those 3, A, B, and C, and whichever one has the greater miles in 1 hour, that's going to be your fastest speed. Okay, so if we find the unit rates here, let's first find the unit rate of A, 3 miles in 1 hour. So on number 2, we got 3 miles. I'll put that on top. 3 miles in 1/3 of an hour. 3 miles per 1/3 of an hour. Okay, so that's the rate. Let's find the unit rate. So to find the unit rate, I need to have a denominator of 1, right? So how did I get from 1/3 to 1? I multiplied 1/3 by what to get to 1? I multiply by 3, right? 1/3 times 3 will give me 1. And so if I multiply by 3 on the bottom, I have to multiply by 3 on the top so that this new rate is equivalent to the first one. So 3 times 3 is 9. And my unit on top is miles. So I'm going 9 miles in 1 hour. If I go 3 miles in 1/3 of an hour, that means I go 9 miles in 1 hour. Okay. Now, I could also look at it like this. I'm taking the top and dividing it by the bottom. 3 divided by 1/3. 3 divided by 1/3. Right, I can write 3 as a fraction by putting it over a 1. So here I'm taking a fraction divided by a fraction, so I would use KFC, right? Keep, flip, change. So if I keep the first one, if I keep 3 as 3 over 1, I flip 1/3, the reciprocal of 1/3 is 3 over 1, and then I change to multiplication. I have 3 times 3, which is 9, right? Which is what I got right here, 9 miles per hour. So either way you want to think about it will give you the same answer. All right, so option A is 9 miles per 1 hour. So we have to do the other two, letters B and C, to figure out which one's the fastest in miles per hour. Okay, so let's go to option B. Option B, we have 1/3 of a mile in 3 hours. Okay, that's the rate in the problem. So let's find the unit rate. We want to figure out how many miles do I travel in 1 hour. So I could set it up like this. This is equal to so many miles per 1 hour. And so I think to myself, how did I get from 3 to 1? What am I doing on the bottom? Well, I am dividing, right? I'm dividing by 3. 3 divided by 3 gives me 1. And so if I divide by 3 on the bottom, I also have to divide by 3 on the top so that I have an equivalent rate. So 1/3 divided by 3 gives me the number of miles per 1 hour. So I have 1/3 divided by 3. And I'll write 3 as 3 over 1 so that it's a fraction. So now I got to use KFC, right? Because I'm dividing fractions. KFC. So I keep the first one, 1/3. Flip. If I flip 3 over 1, it becomes 1 over 3. And then I see change to multiplication. So I have 1/3 times 1/3, which gives me 1/9. So I have 1/9 miles per hour. 1/9 miles per hour for B. So as I can see, A is obviously faster than B, right? A goes 9 miles in 1 hour, and B only goes 1/9 of a mile in 1 hour. So right now, A is the fastest. So let's check on C. C, it says I have 1/2 of a mile in 2 hours. Okay, so to find the unit rate, I could just take the top and divide it by the bottom. Right, that's the same thing that I did here. 1/3 divided by 3 give me 1/9. So if I take 1/2 and divide it by 2, 1/2 divided by 2, and I can write 2 as 2 over 1, right? Again, I use KFC. Keep, 1/2 stays the same. I flip this one. 2 over 1 becomes 1 over 2, and I see change to multiplication, so I have 1/2 times 1/2 equals 1/4. Okay, so the equivalent rate here, if I go 1/2 of a mile in 2 hours, that means I'm going 1/4 of a mile in 1 hour. So here are my unit rates. 9 miles per hour for A. For B, I have 1/9 of a mile per hour, and for C, I have 1/4 of a mile in 1 hour. And so what is the fastest one? The fastest one would be A, right? Because it goes 9 miles in 1 hour. So circle letter A for number 2. Okay, number 3. Number 3 says if 2.5 pounds of cherries cost $6.25, what is the unit price? So I want the cost per pound. Cost per pound. That's what I'm looking for. Okay, so I can set it up like this. I need to write my rate. This is number 3. The rate given to me in the problem is it's $6.25. So I'll put $6.25 up top. And it costs $6.25 for 2.5 pounds. I'll use the abbreviation LBS for pounds of cherries. So this is the rate, right? I have cost on top. The horizontal fraction bar means per, cost per pound. Cost per pound. So right now it's $6.25 for 2.5 pounds. I want the unit price, or the unit rate. The unit rate, or the unit price, which means I want the cost per 1 pound. I want the cost per 1 pound of cherries. Okay, so what I can do is like before in number 2, I take the top and divide it by the bottom. $6.25 divided by 2.5 will give me the amount of money it costs for 1 pound. Right? Because look what I'm doing here. I'm dividing 2.5 divided by 2.5 is 1. And so if I divide the bottom by 2.5, I do the same thing to the top. I divide $6.25 by 2.5 to get the cost per 1 pound. Okay, so I take 625 divided by 2.5. I need to set this up as a division problem like this. 625 divided by 2.5. All right, if I look back at my original rate, this one right here, the top number goes inside, 625, and the bottom number, 2.5, goes outside. Top number inside, bottom number outside. Okay, now we learned about this in chapter 3. Whenever I divide decimals, I cannot have a decimal point outside the division bracket. And so what I have to do is move the decimal one place to the right. So I show how I move it by a little arc right there. Okay, so my decimals are now right here. So I need to rewrite the division problem. 2.5 now becomes 25. That's on the outside. And 6.25 becomes 62.5. Okay, now I can divide because I no longer have a decimal outside the division bracket. So now I think to myself, how many times does 25 go into 62? And I should say 2. 2 times 25 is 50. I subtract and get 12. I've got to bring down the 5. My decimal point stays right there. So now how many times does 25 go into 125? Well, it goes in 5 times. 5 times 25 is 125, and I get a remainder of 0. Okay, so this right here will give me my price per pound. So that's what I put in right here. Now I got to think about this in terms of money. What is 2.5 in terms of money? Well, remember, we can always add a 0 right there, and when we're talking about money, you only have 2 digits after the decimal point. So 2.5 means $2.50. $2.50 per 1 pound. That's the unit rate. It costs this much per 1 pound. So this is my final answer. That's the unit rate. $2.50 per pound. Okay, number 4. I have a table here, 3 tables. Which table shows a constant rate of change? A constant rate of change. That's what I'm looking for. Okay? So remember the equation that we use, the equation that we learned in lesson 6.2 is y equals k times x. Y equals k times x, where k is the constant rate of change. And so if we want to find k, what we can do in this equation is divide both sides by x. And so k would equal this, y divided by x. So if we want to find k, take y divided by x. All right, so we'll go back to the original worksheet here, and let's let hours be x, and we're going to let the earnings or the money be y. Okay, so hours are x, earning is y. And what we're going to do is we're going to divide y by x, and if we get the same answer, then we know that that table has a constant rate of change. All right, so let's check B. So table A. As you can see, they all have a first row of it costs $40 for 2 hours, $40 for 2 hours, $40 for 2 hours. Okay, so let's divide y. Take y, which is 40, and divide by x, which is 2. 40 divided by 2. If I do 40 divided by 2, I get 20. Okay, so far k is 20 in this first column right here. Now let's check the second column. So here I have 60 divided by 7. 60 divided by 7 does not equal 20. Right? It does not equal 20. So I know I can eliminate table A because I don't have a constant rate of change. If I take y and divide by x, I don't get the same number. Okay, so A is eliminated. Let's go to table B. Table B, I have 140 over 7. 140 divided by 7 is 20. Okay, so table B is good. Table B is good. Let's check table C. Table C, I have 70. 70 divided by 7, which is 10. Right? 10 is not 20, and so Table C does not have a constant rate of change. That leaves me with only table B. Okay, so I've already had 40 divided by 2 is 20. 100 divided by 7 is 20. Let's check if 280 divided by 14, that should be 20. 280 divided by 14, that is in fact 20, right? Because 20 times 14 is 280. And so as you can see here, this table, table B, has a constant rate of change, because if I take the y values and divide them by the x values, I always get a result of 20. So B for number 4. Okay, number 5 says a student studies the same amount of time each day for a test. In 4 days, she studies 60 minutes. Which equation shows this relationship? Let x equal the number of days, and here's a hint. Find the unit rate in minutes per day first. Okay, so for number 5, I'm first going to write the rate in the problem. I'm going to write the rate so that I can find the unit rate, which was the helpful hint given to me. So the rate in number 5, the student studies for 60 minutes. This is the rate. The rate is 60 minutes in how many days? 60 minutes in 4 days. That's the rate. Okay? So let's find the unit rate, which means how much time did she spend studying in 1 day? If she spent 60 minutes in 4 days, how many minutes in 1 day did she study for? So I could take 60 and divide it by 4, because that's what I'm doing here. I would divide the bottom by 4. 4 divided by 4 is 1. And so on the top, I take 60 and divide by 4, and that will give me the number of minutes per day. So I can come over here to the side and set that up. 60 divided by 4, again, top number goes inside, bottom number goes outside. 4 goes into 6 one time. 1 times 4 is 4. Subtracting it 2, bring down the 0. 4 goes into 25 times, and 5 times 4 is 20, so I get a remainder of 0. And so I take this quotient that I got, 15, and I plug that in right here. And so if she spends 60 minutes in 4 days, that means her average is 15 minutes per 1 day. Okay? So we have to choose the equation. We have to choose the equation in number 5 that shows this relationship. Okay, so if our constant rate of change is 15, then in the equation y equals kx, where k is the constant rate of change, I plug the k value, which we just found was 15, I plug that into the equation, and so I get y equals k is 15x, okay, which is letter B. Y equals 15x. Number 6 says use this graph for number 6 and 7. It should just say number 6. We're just going to use the graph for number 6, not number 7. It says draw a line through the points. Okay, so I want to draw a straight line through the points. Okay. Why does this line show a proportional relationship? Why does this line show a proportional relationship? Is it A, because it's a vertical line? Well, that's not true. It's not even a vertical line. A vertical line goes up and down. This goes diagonal. Letter B, it goes through the origin. What is the origin? The origin is 0, 0. Here's the origin right here. Okay, that's the origin. And C says it's not curved. Well, the only one that shows this is a proportional relationship is letter B, the fact that it goes through the origin. Okay, now you're going to have a question like this very similar on your test, and you got to know this. To be proportional, the line must go through the origin. To be proportional, the line must go through the origin. If the line does not go through the origin at 0, 0, then it is not proportional. Okay, that's very important. To be proportional, it has to go through the origin, which is at 0, 0. All right, number 7. If a person walks 2.4 miles in 1.5 hours, how far can he walk in 3 hours? So let's first write the rate given to us in the problem. 2.4 miles in 1.5 hours. Right? This is the rate. That's the rate in the problem, right? We're comparing miles to hours. And so here we basically want to find an equivalent rate. If he walks this far in 1.5 hours, how far does he walk in 3 hours? How many miles in 3 hours? So as you can see, look at what we're doing on the bottom. If we take 1.5 and multiply by 2, 1.5 times 2 is 3. And so if we multiply by 2 on the bottom, we have to do the same exact thing on the top. So I take 2.4 and multiply by 2, and that will give me the number of miles in 3 hours. So I have to set this up as a multiplication problem. I got 2.4 times 2. Remember, when multiplying with decimals, it does not matter as far as lining up the decimals. We ignore the decimals to begin with. So I multiply as normal. 2 times 4 is 8. 2 times 2 is 4. Now I got to place my decimal. How many digits do I have after decimal points? Well, I only have 1. So I start on the far right, and I go 1 place to the left, right there. So how many miles does he walk in 3 hours? 4.8. Okay, so my answer is 4.8 miles. Okay, let's go to the back side. Number 8 says complete the table for an object that goes 40 miles in 1/4 of an hour. It goes 40 miles in 1/4 of an hour. All right, so as I can see here, I'm comparing miles to hours. For 1/4 of an hour, I go 40 miles. And then in the table, it has 1/2, 3/4. Now, I know that 1/2 is equivalent to 2/4. Would you agree? 1/2 is the same as 2/4. And so what's happening to my time increments is that I'm going up 1/4 each time. I have 1/4, 2/4, which is the same as 1/2, 3/4, 4/4, 5/4, and so on. And so what I could say here is that for each 1/4, each time I go to the right 1/4, I go how far in miles? 40 plus 40. And so I can fill in the table with 40 plus 40 is 80. Okay, if I go 1/4 more plus 1/4 more, that means I have to go plus 40 more. So this would be 120. Okay, so each time I go to the right, I add 1/4 of an hour and 40 miles, right? Because that's my rate. For every 1/4 hour, I go 40 miles, and so on the top, I'm counting by 40s, and on the bottom, I'm counting by 1/4. Number 9, find K, the constant of proportionality for the data in the table. Then write an equation for the relationship. Okay, so I want to find K. Remember, the equation that we're using is y equals K times X. That's the equation. But if I want to find out what K is, what I can do is to get K by itself is divide both sides of that equation by X. And so these X's would simplify, and K would be equal to this, y divided by X. Okay, so now I can use this equation to figure out what K is based on this table. So I take my Y values and divide them by X. So 250 divided by 25. That would be K equals 10, right? Because 250 divided by 25 is 10. Let's check the next one. 500 divided by 50 gives me 10. 750 divided by 75 gives me 10. And one more to check. 1,000 divided by 100 equals 10. So as you can see, if I take my Y values, divide by my X values, I get the same thing each time, which means I have a constant rate of change. K is 10. So that's the first part. It said find K. K is equal to 10. All right, but then I need to write an equation for the relationship. So the equation, the original equation, is y equals K times X. And so if I know what K is, I can plug the value of K in for K in the equation. So my equation is y equals K is 10x. This is my equation. So based on the data in this table, I get this equation, y equals 10x. Okay, number 10 says create a table. Well, actually the table is already created for you, that shows a proportional relationship. Then use your table to find the cost of 12 pounds. So we want the cost of 12 pounds. There's a typo right here. It says the cost of 10 pounds. Just cross that out and make it 12. We want the cost of 12 pounds. Okay? So what we can do here is find what K is. Remember, to find K, I simply take my Y values and divide by my X values. let's let the number of pounds be x and the cost be y. So if I take the cost and divide by the number of pounds, 6 divided by 1 is 6, so k would be 6. 12 divided by 2 is 6. 18 divided by 3 is 6. So I have a constant rate of change. K is 6 each time. All right, so what I can do for number 10 is I know it's $6 per pound, right? Because that's my constant rate of change. $6 per pound. $6 per pound, and I want 12 pounds. 12 pounds times $6 per pound. 12 times 6 is 72. It would cost $72 for 12 pounds. Okay, number 11 says some hikers had an average speed of 4 miles per hour. Draw a graph to show how the distance is related to the time. Plot at least 4 points. We want to plot, which means you need to put points at least 4 points and draw a line through the points. All right, so we have a coordinate plane here. Our x values are time. This is our x-axis, runs horizontal, and our y-axis, which runs up and down. X and y. Okay, so we want to plot at least 4 points. So let's say in 1 hour, let's let, x is time. Time and distance. Okay, so write that down. X is time, y is distance. So in 1 hour, the hikers will go 4 miles. In 2 hours, they'll go 8 miles. In 3 hours, they'll go 12 miles. And 4 hours, they go 16 miles. Okay, so what these are my points that I can plot on the graph. Okay, so to plot them, I go to the right. I go to the right 1, and then up to 4. So there is, after 1 hour, they go 4 miles. And then I go to 8. So go to 2, go right to 2, and then up to 8. To 8. So after 2 hours, they go 8 miles. After 3 hours, so 1, 2, 3, I go to the right 3, and then up to 12. I make a point. So after 3 hours, they go 12 miles, and then I got one more to do. I go right to 4 hours and up to 16. 16. Okay, so after 4 hours, they go 16 miles. And I could continue doing that, right? For each number of hours, they go 4 more miles. Okay, so I have drawn the graph to show the distance related to the time. I've plotted at least 4 points. Now I got to draw a line. So basically I connect these. I connect them. At the end I should draw an arrow because this is a line. It continues on from this point. So draw an arrow really on both ends because a line never ends in both directions. Okay, notice how this line is going through the origin. So this does show a proportional relationship because it has a constant rate of change and it goes through the origin. Number 12, how far do they travel in 7 hours? How far do they travel in 7 hours? Okay, so if the rate is they're going 4 miles in 1 hour, if that's the rate, and we want to figure out how many miles they went in 7 hours, then as you can see on the bottom, we multiply 1 times 7, right? 1 times 7 is 7. So we have to do the same thing to the top. 4 times 7 gives us 28. Okay, so in 7 hours, they go 28 miles. And number 13 asked me to write the equation used to represent the data presented in the graph. And so this graph right here, my constant rate of change, my k, is 4, right? Because remember to find k, you take your y values and divide them by your x values. So if I do that right here, 4 divided by 1 is 4. 8 divided by 2 is 4. 12 divided by 3 is 4. 16 divided by 4 is 4. So that's my constant rate of change. K is 4. So I use this equation. I use y equals kx. Y equals k times x. And if I know that k is 4, just plug that in right there. And so my equation is going to be y equals k, which is 4x. y equals 4x. That's number 13. So this equation is represented by this graph. Finally, last one, number 14, says a bicyclist goes 43.54 miles in 3.5 hours. What is her speed in miles per hour? So if we want miles per hour, you got to put miles on top. 43.54 miles per 3.5 hours. Okay, so this is the rate. That's the rate. We want to know the unit rate. So if she goes this far in 3.5 hours, how many miles does she go in 1 hour? Okay, so as you can see, we're taking the top and dividing it by the bottom. Or I could say to get from 3.5 to 1, I divide it by 3.5. 3.5 divided by 3.5 is 1. And so if I divide by 3.5 on the bottom, I also have to do that to the top. Divide by 3.5. Right, which again is the same thing as taking the top and dividing by the bottom. So I got to set this up as a division problem. I take, I'll just write it over here, 43.54. Top number goes inside. Bottom number, 3.5, goes outside. Now remember, I can't do this because I cannot have a decimal point outside the division bracket. And so to move it, I have to move it to the right to eliminate it. Move it to the right one place. And I got to move the decimal for this number and this number, right? So that it stays the same problem. So on the outside, 3.5 becomes 35. And on the inside, 43.54 becomes 435.4. Okay, so now I can divide. How many times does 35 go into 43? I look at these first two digits. How many times does 35 go into 43? Well, one time. 1 times 35 is 35. I subtract and get 8. Have to bring down the 5. How many times does 35 go into 85? It goes in twice. 2 times 35 is 70. I subtract and get 15. I got to bring down the 4. My decimal point stays right there. How many times does 35 go into 154? Well, it goes in 4 times. 4 times 35 is 140. I subtract and get 14. I got to add a 0 so that I can bring it down. How many times does 35 go into 140? It goes in 4 times, exactly 4 times. 4 times 35 is 140, and I get a remainder of 0. Okay, so how many miles per hour? This many, 12.44. I'll plug in right over here. 12.44. I can rewrite it like this, 12.44 miles per hour, or miles per 1 hour. That would be my answer. Okay, so now we should have study guide number 1 completed, since you have followed along on this video. So your homework tonight is study guide number 2. Have that completed. I'll check both these study guides tomorrow in class. Remember, our Chapter 4 test is on Friday.